we have is basically, again, something like this, and then, so you have a little internal resistance, you have the EMF, and then you have an external load here. External load meaning outside of the battery. This yellow box right there is like the battery. Okay, so then they're saying you take this battery, hook it up to a light bulb, whatever it is, and then they want to know what is the power being used up by the external battery. Oh, they also gave us the current, I believe, which is 0.16 amps or something. Okay, so that's key because they asked for power. What equation do we use for power? Okay, well, there's like several of them. The basic one is just IV, right? Now, when you use IV, if I use I, that's the current through the whole thing. If I use V, that is the EMF. That will give me the total power. Does it make sense to you that the total power consumed by the whole circuit is equal to the power of the little resistor plus the power of the big resistor? Right? Because each resistor is going to use up some power. Those two resistors combine to be the total. So if I want to know, do you see that this power of the big resistor is what I label power external right there? So then what I can do is I can say the power of the big resistor, which is equal to the power external, that's just a naming convention, is PT minus PR. So PT, I'm just going to use IV, and then PR, I'm going to use I squared little r. Okay, and then when you multiply that together, I don't know what you get. Somebody do that. What's 0.16 times 1.54? 0.246 minus 0.16 squared times 0.25. Or is this the answer total?
No, that was just...
Oh, okay.
Sorry.
No, that's fine. What's I squared r? 0.16 squared and then times 0.25. I guess 0.64? 0.0064. So then if we do that, that gets rid of that. So basically we're left with a power of 0.24 watts. Or close to it. And then now they want to know how much energy does it use in a minute. Well, what is the equation for power? What is power? Power is what over what?
Oh, Q over T.
Okay, it could be Q, could be W, could be E, right? Because all of those things are in joules. So it's energy per time. Very good. So then if I want to know the energy is going to be equal to power times time. So it's going to be 0.24, and then they wanted a minute. So that's, a minute would be 60, so it's around, what, 14 seconds? I mean, 14 joules.
Yeah, 14.4.
14.4 joules, and we are done. Yeah, so it's going to be 0.24 watts times 60 seconds, because they said in a minute, but remember, what is the fundamental unit of time in physics? It's a second. Any other questions?